Greetings, my name is Jeremy Alicea, and to those that are watching, I belong to the Solar Autonomous Boat Project. With me are members Fabian Matos and Pedro Madera, along with our advisor, Professor Guillermo Serrano. In this presentation, we will be talking about our progress throughout the semester and the tasks and goals for the next semester. Before going into details about the project, first we must explain what it is all about. Since solar energy has had an exponential growth in its usage, the implementation of autonomous vehicles with this technology has grown as well. With this in mind, the main obstacle these vehicles have is the implementation of a motion control system. Now, for the main objectives of the project, we have set three main goals. 1. To develop and manufacture a frame for the autonomous vessel along with performing tests for said vessel and confirm the boat's mechanical behavior. 2. The implementation of autonomous system and its integration with the motion control software. And 3. To design a solar powered system to integrate it with the autonomous software. With this, I'll leave you with Pedro Madera, who will be explaining the progress made with the design of the boat this semester.
Hi, I'm Pedro Madera. I'll be explaining the design of the boat. The vessel was designed having in mind the following requirements, which are to use Formula 250 foam attached to thrusters and add solar panels. It was used the program SolidWorks 2020 Student Edition to realize the boat, which all dimensions are in the English system of measurements. As a result, we have a boat of 16 inches of height, 8 feet of length, which are 96 inches, and finally 4 feet of width, which are 48 inches. On the right we can see the figure 1, which is the isometric view, top view, back view, and side view of the boat, with all the dimensions in inches. Using the side view as a reference, we can see that the bottom part of the vessel, which height are 8 inches and 2 inches, is made of the material Formula 250, a low density foam. The upper part of the boat, which has a height of 6 inches, is made with EPS foam, which is expanded polystyrene. At the lower left end, which is the color black, are the thrusters on the boat. Finally, taking the top view as a reference, we can see the solar panels, which have a width of 42.1 inches and a length of 20.9 inches. There are 3 of them, each separated by 0.1 inches. In order to determine the minimum volume of buoyancy needed so the boat can float, it was made a free body diagram with the forces acting in the y-axis, which was made with the program diagram.net. There are several forces acting downwards, meanwhile the only force acting upward is the buoyancy. Using the previous diagram, it was developed the sum of forces in the y-axis to determine the minimum volume that the boat needs to float. On the right, we have the figure 3, which is the calculation made with the program MathCAD Prime. Underneath of the figure, there is a legend explaining the meaning of each variable, which V is the minimum volume that the vessel needs to float. As a result of this calculation, we have that V is 1.402 feet cubed. Taking the volume of the catamaran of the SolidWorks CAD, we have 8.45 feet cubed. If we make a comparison, the volume of the catamaran is greater than the minimum volume needed. This means that the boat can float with the applied forces. It was required to search for the center of mass in order to establish where the storage box and the battery will be located. It was used 2 techniques in the program SolidWorks to find the center of mass. First, it was applied the physical property tool. As a result, it gave us the following length: 37.36 inches at the x-axis, 11.64 inches at the y-axis, and negative 24 inches at the z-axis. The z is negative because the vessel is located in the negative side of the axis, meaning it's truly 24 inches. It was verified this fact using the reference geometry and measure tools to have a clear thought where the origin point is located. Now I'm going to leave you with Fabian Mato, which is going to talk to you about the autonomous software.
Thanks, Pedro. The software we will be using is the ArduPilot rover. The ArduPilot software specializes in RC and autonomous vehicles. This version works for rover-type vehicles, but its frame type can be changed to that of a boat. Since rovers use almost identical parameters to a boat, all that is needed to be done is change set parameter, and the additional necessary parameters will be set accordingly. Before sending the boat to water, we must first upload a set of coordinates for the boat to be able to start its missions. Softwares like GQ Ground Control and Mission Planner give us the ability to upload coordinates and to change course on real time by setting new waypoints. They also give feedback on all the components of the system for real-time monitoring. To be able to perform the task I mentioned before, we must know the necessary components of the system. The main component is the 32-bit Pixot PX4 2.4.8 flight controller ARM computer. This is connected to the GPS and compass, a safety switch, telemetry radio, RC receiver, power module, which in turn is connected to the speed controllers and the Bluetooth Robotics T200 thrusters, and the battery bank. Since the system will be exposed to water constantly, we must secure its components in a compartment within the boat. For this task, the team chose the Altalix waterproof utility box. Within this box, the team designed a platform for the system to rest on. This platform was 3D printed. The platform would be placed and secured in the box, and any components that would need to be outside, such as the GPS, would be connected to the design holes in the box and sealed to prevent water from getting into the box.
Overall, with the implementation of ArduPilot system and the complete manufacture of all the boat's pieces, next semester the team will be able to mount the boat together along the components of the ArduPilot. With this, the team estimates to have a successful and complete design by March 2021. Even though the boat can travel large distances, for future goals, the team plans to change the operating system of the software in order to collect more data during the boat's mission.